Hello and welcome to this lesson here where we're going to be taking a look at triangles, angles, and Pythagorean theorem. This is a introductory lesson on trigonometry, and from this we're going to build off of it into trig ratios. But for this video or this lesson specifically, we're going to focus on just triangles in general, as well as a little refresher on Pythagorean theorem. So let's start off with a little refresher here. Triangles. What is a triangle? Well, let's remember that a triangle, the triangle, three angles. Okay, so we have three angles which are made up of three sides. Okay, those right. So it kind of makes sense. Which meet at a vertice. We call it a vertice. That's a corner. Okay, here's our little drawing of a triangle. They meet up at three vertices, three sides, and those are the angles that we can calculate. Now, you might often see kind of an angle measured by that little kind of thing there, and we have three of them inside this triangle. Okay, so 1, 2, and 3. Now, we can also label them a little bit. We could say like that's angle B, this is angle A, that's angle C, and there we go. We have our triangle, right? So we have our three angles inside of our triangle. And this is just a way of describing a triangle and really what it is. Now, I'm guessing most of you already know what a triangle is. It's just a little bit of a refresher. The length of a side can be measured in many different units. Okay, so we could measure it in inches, in centimeters, in feet, in miles, in kilometers, whatever, fathoms if you really want to. You can measure it in many different units, but the size of the angle we are always going to measure in degrees. There are different ways of measuring angles. Okay, so we can measure them in degrees, we can measure them in radians, but we're going to measure it in degrees. That's what we're going to focus on in class. Now, do you know how many degrees are in a full circle? Hope you said 360. Yeah, so a degree, there's a little symbol above, is 1/360th of a circle. Okay, so when we measure a degree, we're measuring an angle. Okay, how big an angle is, what portion of that 360 degrees is that angle? Okay, is it 90 of those? Is it 25 of those? Okay, that's what we're measuring when we're talking about the amount of our circle there. So to simplify it a little bit, we're usually just going to put A, B, and C around our triangle, and then we can measure an angle. So let's focus firstly on, let's look at angle A. Okay, you see angle A, that one right there in the bottom left corner. We might not necessarily have a nice triangle. We might have other pieces, and A is the vertice of that point. So if that is the case, we can represent that angle like this, angle CAB. So it's going to go from C to A to B. Oh, that way. Ha, yeah. Okay, tried to draw it out. Okay, so C to B to A to B. Haha. Okay, my camera's a little off there. That is how we would measure that angle. So that's telling us we're trying to find that angle A. We can do the same thing with B. That's going to be ABC. Ah, that's a nice one. And this one here is BCA. And order does matter. I'm not too worried about order right now, but in later courses, I would be more specific about order. All right, let's look a little more at angles. Here we have an angle. Okay, it's a nice little angle. This is what we would call an acute angle. A little bit of descriptions. This is any angle that is between 0 and 90 degrees, not including those, but just above 0 and just below 90, and that would be an acute angle. It's so cute. If you don't think of it that way, I think of it, it's small, it's cute, we'll call it that. So acute, if that helps you to remember what they're called. If we have this with a square in the corner, we call this a right angle, or it's a 90-degree angle. Okay, so we're going to look a lot at these right angles and how we can use them going forward. If we have more than 90 degrees, we call this an obtuse angle. It's a big angle, obtuse. Okay, I just feel like it's a big word that you can use. Obtuse angle is any angle between 90 and 180 degrees, and so that would be an obtuse angle. Those are really, we're going to use the first two, acute and 90-degree angles. Maybe in future lessons, we're going to look at obtuse angles as well. There are two more that we could do as well, and I'm just going to kind of go over them really quickly. The first one is just a straight line, or really two straight lines that meet at a point, okay, or two lines that meet at a point and they're horizontal to each other. And this would be called a straight angle. It's 180 degrees. And if we get anything bigger than 180 degrees, we call it a reflex angle. So it's anything between 180 and 360 degrees. So those are just names of the angles, and we haven't a way to describe them, again, going forward. All right, a triangle which has a right angle is called a right angle triangle. This is the kind of triangle we're going to use a lot in this lesson and in this unit on trigonometry. We're going to look at right angle triangles. The other two angles that we have are called acute angles because they are smaller than 90. And if we happen to add up both those angles, they will equal to 90 degrees. So that's something that we can be aware of. Now, when we decide we want to label, we can put different letters on there. I'm going to put A, B, and C onto there. And this is a little bit of review of my past lessons. A and B are our legs, C is our hypotenuse, and if we know two of those sides, we can find the third using Pythagorean Theorem, which is a squared plus b squared is equal to c squared. Now, if we're given the hypotenuse, we have to rearrange that, and then we're going to do c squared minus b squared is equal to a squared. So that's kind of some general knowledge that comes down to what you might have already known using in a different level of math. All right, are we ready for some examples? Here's some examples. What I'd like you to do is, with a partner or on your own, grab a piece of paper and pause the video, solve for the hypotenuse in this case, and once you have your answer, come back and we'll see if you got the right answer. All right, so let's try to find that correct answer. Now, in this case, we're going to use Pythagorean Theorem. I'm going to label my triangle. I know that C is the hypotenuse there, and then the other two sides are A and B. So because we're given A and B, we can just plug them in and solve. So A squared plus B squared is equal to, well, in this case, 29 square inches. That might sound kind of weird to say 29 square inches, but it is in fact the way that we would write this out. Now, that is not our C value. I should put C in there. That is a typo on my part. Take the square root of those, and we should get a distance for C, not A, to be 5.39 inches. Okay, so that's what you should get as your answer. I hope that you got that, and that's the hypotenuse. Quick little reminder, hypotenuse needs to be the longest side, and so therefore it has to be longer than the 5. In fact, in this case it is. And because it's the distance between these 2 points, and if we go the long way, that would be 7 inches. It's got to be less than 7. So it's just a little check for us. It's got to be somewhere between 5 and 7 inches. Try this one out. Pause the video. Come back when you have your answer. All right, let's see if we can find our answer. All right, we're going to use Pythagorean Theorem. We have A and B. We're trying to find C. So we're going to plug it into our formula. 13 squared plus 17 squared becomes 458. Okay, now that is our C value. This time I did it right. We take the square root of both sides because that is C squared, not just C. And we're going to get a side length of 21.4 yards. Did you get that? Good. Yeah, I hope so. I hope that was a positive. All right, so that's finding that side. So far, so good. Let's do a word problem here. We have a field is in the shape of a square with a side length of 0.5 miles. What is the diagonal of the field? So diagonals from corner to corner. All right, draw a diagram, solve, pause the video, come back when you have your answer. All right, let's see how you did. I'm going to draw my diagram. There's my square. What a perfect square. I'm sure all your squares were perfect as well. I'm assuming so. We're told the side length, and we're asked to find what the diagonal is. Now, because we're given a square, we understand that all of the corners are 90 degrees, so we can use kind of half the square as a right angle triangle. We're going to use our a squared plus b squared equals c squared. We're going to put our a, b, and c on there, plug it in, and we get an answer of square root 0.71 miles. So if you have a half mile square yard, the diagonal would be 0.7 miles long. And that's something that you could think about or use. Maybe. Who knows? All right. Next one. Let's find the missing side there. Pause the video. Come back when you have your answer. All right. Label. We're going to find our A value because we're given our hypotenuse. So therefore, our A value has to be smaller than 15. It's important that we know that. And again, the other value isn't really going to help us a whole lot. But let's solve for it. So we're going to do our hypotenuse squared minus the other side squared, and that should give us a squared. So 15 squared minus 12 squared gives us 81. The square root of 81 is 9, so therefore our C value is 9. All right, not too fast. So far, so good. Yeah. All right. Find the next one. Let's do another example. See how you do on this one. Label, solve for side KL. Okay. Again, we're given the hypotenuse, so we're going to be using c squared minus b squared is equal to a squared. 10 is c, 5 I'm going to call b. If you want to call that a, that's fine. Just either one is totally fine there. Plug them in. 10 squared minus 5 squared gives us 75. We need to take the square root of 75, and we're going to get an answer of 8.66 inches. Now, in my class, I'm going to ask that you always round to 2 decimal places. Okay. Once we get to angles, we'll do to the nearest degree. But for any measurement, please round to 2 decimal places. All right, let's do an example, a word problem. Draw out a diagram, solve for how far up the wall does this 15-foot ladder reach if the base of the ladder is 6 feet from the wall. Okay, here we go. I'm going to draw out a little diagram. There is my floor and wall. My ladder goes up the wall there. The ladder is 15 feet long and the base is 6 feet from the edge. And because we're dealing with a wall, we're always assuming it's straight up and down. We're assuming that the builders did a good job with it. Doesn't always happen, but hey, we're going to assume in this case. And so that's going to be at a 90-degree angle. We're finding the side length, so we're going to use c squared minus b squared equals a squared. Plug our values in there. 15 squared minus 6 squared gives us 189. The square root of 189 is 13.75 feet up the wall. If you're given a word problem, also please give a little word description as to what the answer is. Show all your work, show how you're coming up with your answer. That's the end of this lesson. I hope that you've learned a little something. I hope that you maybe remember a little something as well. And I hope that you are prepared to do the assignment as well. Thank you so much for watching. Have a wonderful rest of the day.